All right, number 16, we're graphing f of x equals 2 raised to the x and g of x equals log base 2 of x on the same, I don't know why it says grid, graph, whatever. All right, so let's graph f of x equals 2 to the x first. So, all right, so for the x values for the exponential graph, the easiest ones to use are always just -1, 0, and 1. Okay, you don't need to use all 5 points, but you can if you want to. So, if you really wanted to, you could do -2, -1, 0, 1, 2. All right, and then you got to see what each of these values are. 0 is the easiest one because when you raise anything to the 0 power, do you know what it is? Do you remember? It's 1. That's right. So 0, 1 is a point. And then obviously 2 raised to the first power is going to be what? 2 raised to the first power. 2, yeah. 2 raised to the first power is 2. Then 2 raised to the second power, or 2 squared, is going to be 4, right? And then how do I get the negative exponent values? Do you remember? If I have 2 raised to the first is 2, then 2 raised to the negative first is going to be 1 over 2. That's right. So then 2 raised to the negative 2 is going to be 1/4, right? 1 over 4. All right, so I'm going to go ahead and graph this exponential. So we got -2, 1/4, like about here. -1, 1/2, like about here, 0, 1. 1, 2, and 2, 4. So yeah, an exponential is supposed to look like this, going up at an exponentially fast rate. Boom, there it is. And let's go ahead and write the attributes for this exponential function. So looking at that, what would the domain be for an exponential function? How far left does this graph go, and how far to the right does this graph go? Yeah, negative infinity to positive infinity. You can see that there's arrows on both the left and right side, so it never stops going left or right. What about the range, though? What's the lowest y value on this graph? Yeah, y is greater than 0, so you can write it like this, where it's not parentheses 0 because you don't actually touch 0. Up to infinity, like this, 0 to infinity. Or you can write y is greater than 0. And what about the asymptote for the exponential graph right there? Y equals 0, right. Y equals 0, the x-axis, is the line that graph's never going to touch. All right. So once you have the exponential graph, it's really easy to get the logarithmic graph because all I have to do for the logarithmic is switch my x and y values. Because if you remember, logarithmic function is the inverse of exponential function. So instead of having -2, 1/4, I'm going to have 1/4, -2. 1/2, -1. 1, 0, 2, 1, and 4, 2. Oh, I'm going to do this in a different color. This will be in the pink. 1/4, -2 is like right here. 1/2, -1. 1, 0, 2, 1, and 4, 2. So you can see it's kind of it's a mirror image across the y equals x line. So if you're able to get all the attributes for your exponential graph, right, you don't really need to do any work to find the domain or range because it's the inverse. What did I do with the x's and the y's? I switched them, right? So that means all I have to do to find the domain and range for my logarithmic is switch my domain and range. So what is my domain here?
0 infinity.
Yeah, 0 to infinity, and then what would my range be? Exactly. If I'm switching my x's and the y's, well, domain's x and range is y, so all I have to do is switch my domain and range. Okay, and then what is the asymptote here then?
X equals 0.
X equals 0, right. Instead of y equals 0, it's going to be x equals 0. That is number 16.